Hello my dear young friends, welcome back to C level physics. Today we are going to deal some numericals based on projections of uniform circular motion, right? So these are the sums which are having some scope to appear in forthcoming NEET JEE mains exams, right? Let us see the model number 3. Already we have completed two models. Now it is the turn of third model, that is to find maximum separation between particles in simple harmonic motion. Maximum separation between particles in simple harmonic motion. So question, see here two particles are in SHM with same amplitude and same frequency along the same line about the same mean position. During SHM, if their maximum separation is root 3 times their amplitude, find phase difference between SHMs. So this is the given question. Here, the motion of particles can be taken as uniform circular motion so that their projections are in to and from motion about fixed center. So here we can take the oscillations of projection as simple harmonic. So here I am representing the motion of two particles in uniform circular motion like this. Uniform circular motion like this. Right? See what xy plane. Suppose let P be the one of the particles. This is the position of the particle, for example. What is the amplitude here? Let be A. Amplitude is A. So it is going in anti-clockwise as shown. Alright? Here, one more particle is there on the same circumference, somewhere here. So this is what Q. So moving along the same circular path. Right? Now, by this instant, when P and Q reaches as shown. Now what is the phase difference between these two here? Pi is the phase difference. Now what is amplitude of second particle Q? This is also A1. Right? See, this is x-axis, this is y-axis. So both particles are moving in uniform circular motion along the same circle with same amplitude and same angular frequency. Right? So that's what given sum. So at this instant, what is the separation between maximum separation between these two here? Root 3 times their amplitude. Now I want to consider a normal onto y-axis like this from point particle P here. Now this is what y projection of particle P. At the same instant, I want to draw one more normal from Q to y-axis. Now this is what projection of second particle Q. Now here in question, now what is the maximum separation between these two particles during their oscillation? Means root 3 times their amplitude. Of course, I took both particles moving along uniform circular path. So here the separation between tips of the projections is equal to given separation, maximum separation. So from here to there, from here to there. Now what is this separation? Root 3 times their amplitude. See here, this is the tip of projection of Q. This is also tip of projection of P. Now what is the separation between these two tips of projections? That is root 3 times A. So we can take like that. Alright. So this is what all these three vectors can be taken outside like this here. See, this is what one A bar. This is what another A bar. Now what is the separation between these two? Root 3a like this. Root 3a like this. Root 3a. So I took all the three vectors a bar and root 3a bar as shown here. Right? Without changing their orientation. Now as per the vector laws of addition, see here a bar plus root 3a bar equal a bar. So a bar plus root 3 a bar equal to a bar. That is root 3 a bar equal to a bar minus a bar. A bar minus a bar, is it 0? No. If both are acting in the same direction, then a bar minus a bar equal to 0. But here a bar and a bar inclined at an angle pi. That's what phase difference between the particles when the separation, when the maximum separation between them is root 3 times their amplitude. So a bar minus a bar can't be 0. Why? Because here there is some angle between a bar and a bar. So we should not cancel both. So a bar minus a bar in the sense that is a bar plus or minus a bar. That is a bar plus or minus a bar also. Right? So root 3 a bar equal a bar plus or minus a bar. So this is what? Subtraction vectors. Subtraction of two vectors of same magnitude. Now what is the ultimate principle here? When two vectors of same magnitude are inclined at some angle, what is the difference between them? R equal to P sine theta by 2. So if I consider modulus here root 3 a bar, mod root 3 a bar equal to mod of a bar plus or minus a bar. That is mod root 3 a bar means root 3 a equal to mod of a bar plus or minus a bar. That is subtraction of these two vectors of same magnitude. That is r equal to 2p sine theta by 2. So what is the resultant of these two? That is 2p. P means in the sense amplitude of either of the particles. That is 2a sine theta by 2. Theta means what is the phase difference between a bar and a bar? Pi. So 2a sine pi by 2. A cancel. We left with root 3 by 2 equal to sine pi by 2. That is root 3 by 2 equal sine pi by 2. Root 3 by 2 sine pi by 2 in the sense sine of pi by 3 equal to sine 60 root 3 by 2. So sine pi by 3 equal sine of pi by 2. Sine cancel here. So pi equal to phase difference between these two particles is given by pi equal to 2 pi by 3 radians. 2 pi by 3 radians. Okay, right? Now model number 4, overtaking in SHM model. See here, question: two particles execute SHM with amplitudes A and 2A with the same angular frequency about same mean position. So here we have two particles which are moving along which executing simple harmonic motion with amplitudes unequal amplitudes A and 2A with the same angular frequency. Angular frequency is same, but the amplitudes are different about same mean position, right? At an instant when one particle overtake the other, they are at a position a by 3 from mean position, right? Now find phase difference between two SHMs. Here also the motion of both particles can be taken along circle so that they move with the constant speed. Am I right? So that's what uniform circular motion about the same center. Then their projections must oscillate with some frequency along straight line in SHM. See here. See, this is what path of first particle. See in XY plane. So with the same center, one more particle moves in another circle concentrically like this, right? See, this is the origin. See, this is what X, this is what Y. So both are moving in circles, concentric circles in the same XY plane as an example. See here, at some instant, this is the position of the particle P, right? At the same instant, this is the position of particle Q, right? Like, so both are moving along same circle as shown, right? Now, what is the phase angle of first particle P here? That is pi 1. What is the phase angle of second particle? That is pi 2. Now, what is the amplitude of P? Amplitude means radius of the circle. What is the amplitude of first particle A? So here it is A. Here it is A. Now, what is the amplitude of second particle? That is 2A. So the radius of outer circle is 2A. Like this, 2A, right? 2A. So here both are having same level from the reference axis X. So therefore, you see at an instant when one particle overtake the other, they are at a position A by 3 from mean position. See, this is the mean position. So they both are at same position A by 3 from mean position in the sense their projections are same from the center O. So what is the projection of P here? This is the normal drawn to Y axis. So this is what? Projection. So A by 3. So same is the projection of even for Q also. Why? Because both are at same level. So from delta, A by 3 is the position of particles from the main position. So therefore, if I take like this, right? So this segment also a by 3, this segment also a by 3. So both are having same projections from the main position, right? Now, if I consider right angle triangle here, see here, if I draw one more normal onto x-axis like that, so we have one right angle triangle here with vertex angle with corner angle pi 1. Here also one more right angle triangle with corner angle pi 2. So from diagram, see the solution from diagram from figure. Sin pi 1 equal to sin pi 1. See this triangle, sin pi 1. So sin pi 1 equal opposite side by hypotenuse. What is opposite side here? A by 3. So a by 3. A by 3 is the opposite side. A by 3 by hypotenuse. See, opposite side by hypotenuse. A. So a cancel, that is 1 by 3. Pi 1 equal what? Sin inverse 1 by 3. Right? This is what? Phase angle made by oscillation of first particle with the reference axis x. In the same way, we can find pi 2 also for second particle. Now take this triangle into account. That is sin pi 2 equal opposite side by hypotenuse. So for second particle, sin pi 2 equal to opposite side. What is this opposite side? Once again, a by 3. So a by 3 divided by opposite side by hypotenuse. What is the hypotenuse? That is radius of the outer circle. In other words, amplitude of particle q, that is 2a. A by 3 by 2a. So a cancel, that is 1 by 2, 3 is 6. So pi 2 equal to sin inverse 1 by 6. Pi 2 equal to sin inverse 1 by 6. So now what is the phase difference between these two? That is here pi 1 is greater than pi 2. So what is the difference? Phase difference here pi 1 minus pi 2. So delta pi equal to pi 1 minus pi 2. That is pi 1 means what? Sin inverse 1 by 3 minus pi 2 means what? Sin inverse 1 by 6. So that's how one can find the phase difference between these two particles. Okay, right. Now model number 5. So in this model, what is that model? Particles crossing each other in s.h.m. So you can find this kind of questions in the NEET as well as JEE also. See here, two particles execute s.h.m. with the same amplitude A and same angular frequency along the same line about same main position, right? It is seen that they cross each other in opposite direction at a distance a by 2 from the main position. They cross each other in opposite direction. That means to say that if I take these two particles move in the same circle, uniform with the uniform circular motion, then their projections are opposite each other. That is the meaning of crossing in opposite. Okay. So what is the given point here? It is seen that they cross each other in opposite direction at a distance a by 2 from the main position. Find the phase difference of two s.h.m. So from data, it is evident that both are moving along circle. Of course, not given, but we can take projection of uniform circular motion as simple harmonic in nature. So that's therefore I am taking like this. Both are moving along the same circle like this, right? So this is what x, this is what y. Okay, this is what O, fixed origin or main position, right? So at some instant, let P be the position of the particle. This is what first particle. So this is a sense of revolution like that. So at the same instant, another particle Q also moves in the same circle in the same sense like this. So that both are at same level from the reference axis xo, x dash, right? Now what is this amplitude? This is also A1. This is also A. This is also A. Why? Because both are having same amplitude, means the radius of the circle remains same for both, right? Now what is the phase angle here for first particle? Let be, that is for P, pi 1 is the phase angle. Now for Q, pi 2 is the phase angle like this, pi 2. So pi 1 is for P, pi 2 is for Q. with respect to reference XOX dash axis, right? Now what is the projection onto x-axis here for both? What is the projection? Means projection in the sense they cross each other in opposite direction at a distance a by 2 from main position. At a distance a by 2. So this y projection is nothing but a by 2. This is also a by 2. A by 2. Now this is what a. This is what a. So radius, otherwise amplitude is a, but the projections, y projections for both particles a by 2, a by 2. That is the meaning here. So they cross each other in opposite direction at a distance a by 2 from main position, right? Now what is the phase difference between these two particles? See here, phase difference, that is pi 1 difference, pi 2. How to find pi 1 here? See here, this is what right angle triangle. Sin pi 1 equal opposite side by hypotenuse. A by 2 by a. Simply we can calculate. So see the solution here. Sin pi 1 equal to opposite side by hypotenuse. So a by 2 divided by a. That is 1 by 2. So implies pi 1 equal what? Pi by 6 radians. Right? Now what about the pi 2? If it is if pi 1 is pi by 6 here, this value also pi by 6. Why? Because both are at same level with respect to reference axis. If this is pi 1 is pi by 6, here this angle also pi by 6. Now what is the angle made by straight line here? Pi radian. So pi radian minus pi by 6 equal to pi 2. So therefore pi 2 also can be calculated like this. That is pi 2 equal to total pi minus this value. So pi minus this angle equal to pi 2. So pi 2 equal to pi minus this value. What is this value? Pi 1. Pi 1 is what? Pi by 6. So pi by 6. That is 5 pi by 6 is the angle. Now what is the phase difference? Very simple. That is delta pi equal to 5 pi by 6 minus pi by 6. That is 5 pi minus pi. 4 pi by 6. That is 2 pi by 3 radians. So 2 pi by 3 is the 2 pi by 3 radians is the phase difference between these two particles for the given data. Okay, right? Now model number 6. See in this question, to find average velocity and average speed in SHM. Suppose here the given sum a particle executes SHM with amplitude A and angular frequency omega, right? At t equal to 0 means at initial instant if it starts from the main position, find average velocity and average speed if first in first 3 by 8th of time period, right? So the motion of the particle can be taken as uniform circular motion so that its projection is in SHM like this. See, this is what uniform circular motion. The given particle is going around the circle with constant speed, for example. See, this is what x, this is what y. At t equal to 0, particle starts from the main position. From the main position, I took xo x dash is the reference. This is what reference axis. If x-axis is the reference, y should be the projection, right? Okay. Now, in a given time, what is the time? 3 by 8th of time period. See here, see the solution. T equal to 3 by 8th of time period. That is 3 by 8th of time period in the sense 2 pi by omega. That is 3 pi by 4 omega is the time, right? 3 pi by 4 omega is the given time in terms of angular frequency, right? In that time, see 3 by 8th of time means it is less than half of the time period and more than 1/4 of time period. Therefore, given t can be taken as t by 4 less than given time is less than t by 2. So within time period, it reaches onto the negative x-axis within half of the time period. Within 1/4 of time period, it reaches from x onto y-axis. But given time is more than t by 4 and less than t by 2. Therefore, we came to know that particle reaches in the second quadrant like this. Why? Because Within one time period, projection raises like that. In next quadrant, projection decreases like that. Right? See here, this was t by 4 plus some small fraction of time. But if you add these two, definitely less than t by 2. So by the time at t equal to 3 by 8th of time period, we came to know that particle, the projection of particle on y-axis retracing, right? So 0 to the projection raises from 0 to plus a and again decreases from a to some value here, right? So this is the position of the particle. For example, at a given time t equal t, this was t equal to 0, at t equal to, this is the position of the particle. Now what is the phase angle required for this fraction of oscillation? It's not complete oscillation, fraction of oscillation. So when it reaches position P, we can take its radius, otherwise amplitude, like that. Now this is what phase angle required by the particle, right? So for that oscillation, fraction of oscillation, this is the phase angle required by the particle. How to get that phase? We know that pi equal to omega t, right? So pi equal to omega t, that is omega into t means what? T equal, in other words 3 pi by 4 omega, that is omega cancel, pi equal to 3 by 4 pi, right? That is 3 pi by 4. Now in that time interval t, 0 to t, now what is the displacement of the particle? See, this is the normal drawn onto the y-axis now. This is what y projection. This is what y projection, like that. Y, right? Y. So as particle starts from mean position, that is at x-axis, that means to say that initial phase is 0. Now what is the valid condition or valid simple harmonic expression here? If particle starts from mean position with the 0 initial phase, so y equal to a sin omega t. Omega means 2 pi by capital T into small t. That is a sin omega, otherwise omega, okay, omega t. Omega into t means what? T equal to 3 pi by 4 omega. 3 pi by 4 omega. So omega cancel. A sin 3 pi by 4. Sin 3 pi by 4 equal 1 by root 2. So therefore ultimately we came to know that y equal displacement of the particle in the time 0 to t is given by, this is what displacement. This is what displacement. It's not displacement. This is what total path length. 0 to a plus a to this position. That is p dash, for example. So 0 to amplitude plus amplitude to p dash, that is distance, path length from here to there and here to there, but this is the displacement. So y equal to a into sin 3 pi by 4 equal to 1 by root 2, that is a by root 2 is the displacement. A by root is the displacement. Now what is the value to be found here? That is velocity, average velocity equal to total displacement by total time. Total displacement by total time. That is total displacement. What is the total displacement here? A by root 2. A by root 2 by total time. What is the time? 3 pi by 4 omega. 3 pi by 4 omega. That is 4 by root 2. 4 by root 2 means 2 root 2. 2 root 2 omega a by 3 pi is the average velocity. Right? This is what average velocity. Similarly, average speed. Average speed is given by total distance covered by the particle during that oscillation divided by total time. Now what is the total distance? Distance means we have to subtract y from 2a. From here to there a plus a. Within one half of the oscillation, what is the total distance? A plus a. But we have to subtract y from a plus a to a. So therefore distance equal to total path length from 0 to a plus a to this position. So we have to subtract y from 2a. That is total distance 2a minus y divided by total time. What is the time? 3 pi by 4 omega. That is 2a minus y. Y means what here? A by root 2. So 2a minus a by root 2 divided by 3 pi by 4 omega. Right? So here a omega is kept common. Omega into a. 4 also goes numerator 4 omega a of 2 minus 1 by root 2 whole divided by 3 pi. So this is the average speed. So 4 omega, see here, 4 omega goes to numerator. If I take a outside, that is 4 omega a of 2 minus 1 by root 2 by 3 pi is the average speed. Okay friends, see you. We'll meet in next video. Thanks for watching.